Everybody, it's Mr. Dean here. Today we're going to go over the Chapter 3 test in Algebra 2X, linear models and systems. Now the video overall will be pretty long. Feel free to fast forward to whatever problem you want and just watch what you need so you don't have to go through the whole entire thing. But let's get right into it. Maybe you're reviewing this for a retake or you're reviewing this for the final exam. Either way, feel free to go through as fast as you need. So there were multiple versions of this test out there, so I'm going to go over the concepts of it, but it may or may not match up exactly with what you had for your own test, your own numbers. So let's get going to it. Number one, this chapter is talking about slope, right? And the slope is a change in y over change in x. So that's what they want. You got a pair of points here, and we just have to be careful. This question has more to do with manipulation of fractions than anything else. So we have our 2 points, x and y, and I've circled the y. So we're going to take negative 1/6, the second y, I'm going to subtract 2/3. Now I could have gone the other direction with it as long as I keep consistent in my next step. Oops, I'm going to erase that and move that back. But I'm going to kind of do it like that. This is just the way that I like to show it, and then I'll do the manipulation of the common denominators in just a moment. So then we'll do the x's. So the x's get subtracted first, right? That x minus that x, since we're going right to left. So I'll try to do it in a different color so it makes some sense here. Separate the numerator from the denominator. All right, now we're going to do the subtraction. We need common denominator. So let's be careful here. Common denominator of 6 and 3 is 6. So we're going to double the bottom and the top. Numerator and denominator, so we have common denominators. And let's see, negative 1/6 minus 4/6 is negative 5/6 for our numerator. For a denominator, our common denominator of the denominator is going to be 6, so we have to make that 3 18/6. So a little tricky there perhaps. And let's see what we got. We got negative 23/6, I think. Negative 23/6. Now we have the classic problem of a fraction divided by a fraction. So let's go over on the side here. Go back to red. We got negative 5/6 divided by a fraction. And I'm going to just simply turn that into a multiplication problem and multiply by the reciprocal. Negative times a negative. And that's going to make our lives easier there. A negative times a negative is a positive, and you can see that all of a sudden it gets quite easy. Slope is 5/23. All right. Number 2, this direction was, the idea of it was that it was going to go for number 2 and 3. So the next two are going to be in point slope form. Point slope form, and you'll see it in just a moment, is the one where you have y and then minus the y coordinate, the minus negative. Y minus negative 7 is like plus 7. Equals the slope, and I want it to be negative 3/2, then the parentheses, and then the x minus the x coordinate. So that's all it had to be. Let me move this over here. Some people, and it's really the same idea, some people learned that you can still have it like y equals, and then all that x stuff. But you can move that plus 7 on the other side by subtracting 7 on both sides, in a sense, and move it on the outside there. Either one of these is fine with me. Either they're the same thing, they're the same idea, they're both would be considered in point slope form. Number 3, now we're looking for a parallel, so we want to grab the slope from this problem. And again, we want it in a point slope form. So I'm going to take the minus 5. It's always minus that number. I'm going to grab the slope, but I'm going to change of course, the negative 4 is now minus a negative 2 plus 2. So the only part that would be the same is the slope from the original problem. All these other numbers, they don't come with us. It's these numbers that are important. All right, and if we were to plug in 5 and negative 2, we'd find out that the line is parallel to this line. They have the same slope. Let's see, slope-intercept form. All right, next, slope-intercept form, that's the one you've been dealing with all the time. Since forever. Slope and y-intercept. So that's more familiar to you, perhaps, than point slope form. Horizontal line passing through 9, 8. Horizontal line goes just like that, and it's going to have a slope of 0 Not a no slope, that's vertical. No slope or undefined slope is vertical. A flat horizontal line has a slope of 0. And when we write it, if I were to write it out all formally, it would be y equals, of course, the slope is 0, x. And then the y-intercept, well, in this case, if I plugged in 9 for x, I'd still have 0. And so my y-intercept needs to be 8. All right? And generally, you wouldn't see it written like that. It could look just like this, y equals 8. All right? It doesn't really seem as though it's in slope-intercept form because it's so simple, but there's nothing much you can do when the slope is 0. You don't really need that part. Number 5, write the equation for the line parallel to this line that passes through 3, -6. Okay. I'm going to start out with y equals 3x, but probably going to need a different number than 7. We can find out by plugging these in for x and y. Sometimes you see, if you have this x and then y, and then you'll see people just plug those numbers in. The x number will end up accidentally, like the 3 will end up in the y spot there, and the -6 will end up in the x spot right there. And you know, that's no good, so we don't want that. So just be real cautious that you sort of switch the order, right? That 3 is going to go in the x right there. It's going to be 3 times 3, and we want the y to be -6. All right, so 3 times 3 there is 9. So let me just see what happened here. I'm going to rewrite. -6 equals 9 plus b. Subtract 9 on both sides. A lot of people had written that it was 3 or 12 or something. I don't know why. Not really sure how that happened. We want the y-intercept to be -15. And we want the slope still. We want the slope to be 3. So final answer for number 5 is y equals 3x minus 15. And that is in the slope y-intercept form. Okay. Moving on, number 6 and 7, both those. Solve for y in terms of x. Okay, we want to get y all by itself. There's one equation, but 2 variables. If we were going to solve for x and y and find out that x and y are what their values are, we would need another equation. It would be a system of equations. But here, we don't know what either x or y is, and we're not going to know. We're just going to come up with an equation, just like this equation. You know, this is that is solving for y in terms of x, actually. So we're going to first try to keep y on this side and move everything on the other side. So if I could add 16 on the other side, and I could subtract 3x, kind of do it all at once. Keep track of what happened here. Those went away. I got 4y equals 16 minus 3x, right? Be very cautious of the signs, the plus and minuses here. Sometimes that can be rotten and mess you up. All right, then we're going to divide by 4, and I got y equals, and there's no rhyme or reason to put what we consider the slope first. So I'll just divide just the way it is. Remember that division, when you're dividing the whole thing by 4, it's really important to realize that you're dividing both of them by 4. And that while 16 divided by 4 is 4, we also kind of have to divide that by 4, the 3x by 4. And you can write it like that, or we can switch the order of them. And you can kind of have the x sort of look a little outside of the fraction. That's also fine. They're all equivalent, so that's fine. This is fine. But you have a y equals, and you have an expression on the right-hand side. All right, this next one here. This one can be a challenge when you have a fraction that's outside of your parentheses. My thought is, everybody often, you're told so much about distributing, but distributing at -2/3 is not the greatest thing. It takes, you know, it can be difficult to do that because of the fraction. So my thought is to take care of this 2/3 right away by multiplying by the reciprocal. By getting rid of this -2/3 first and multiplying by -3/2, multiplying the entire thing on this side by that number, and really the other side, I have to multiply the other side by that number. It's going to take care of that part of it first, right? And it might get a little messy on the right-hand side, depending on what you have on the right-hand side, but it certainly makes the left-hand side very easy. It doesn't change what's in parentheses, because that 2/3 never gets multiplied in, or that -2/3. A little bit of a fraction here on the right-hand side. Remember when you're multiplying fractions, like of a whole number, like 3 over 1, you can see that, and then you multiply straight across. Don't do what a lot of people do, which is to multiply the 3 times that, and then the 3 times the denominator. Because you're actually just, you're getting the same value number. You'd end up in this case with negative 9/6, which is the equivalent to negative 3/2. So think of it as 3 over 1 when you multiply it. And here we are stuck here. And remember, I'm not trying to solve what y or x equals, so I'm pretty much done. All I got to do is subtract 9x on both sides. And I got a nice little, I like that little curly Q there. I got negative 9/2 minus 9x, and I'll leave it like that. I didn't get the curly Q on that 9. And that's it. I could switch the negative 9/2 to negative 4.5, negative 4.5, whatever is necessary. As far as I'm concerned, I don't really care. Either one of those is good, as long as the fraction is reduced all the way. All right, so that was the baby steps. Whoa, we went through all the slides all at once. Let's go back. This is the one we're looking at, because we're getting into solving systems of equations. That is next, and some of these problems get a little scary. Here goes, number 8 in this case. It says to graph these. All right, so we're going to use our skills we just used about solving for y. So y is, I'm going to move the 4x on the other side, negative 4x plus 2. So slope of negative 4, y-intercept of 2. Here we go with this one. I'm going to subtract 6x. All right. So I got negative 6y. Remember the sign before the number belongs to that number. So that's going to end up negative even after you take out the negative 6x. Looks like we're going to divide by negative 6 next. It would have been okay to do that first, actually. We could have divided by 6 right off the bat, everything by 6. But now I got y equals, again, here comes the division. You see it quite a bit. Negative 3 plus x, right? Am I right about that? Negative 3 plus x. All right. Here are our two equations that we're going to graph. Shouldn't be too bad. Let's see, I'll do the second one first. Y-intercept of negative 3, but positive slope of 1. All right. My board is slightly off kilter there, but there we go. Positive slope going through negative 3, right? And then this one is y-intercept of 2. Hold on. I'll matchy the colors here. And it's positive y-intercept of 2. And the slope is negative 4, so I'm going to go down from that spot, down 4 and over 1, right? And there's the spot right there. We'll just keep going. 1, 2, 3, 4, down. And try and make some sort of line there. Good enough? And you can see, and just be careful of this last step. Remember, your answer is not this graph. Your answer is not the graph. Your answer, you have to report what that intersection is. And don't get your x's and y's mixed up, as I'm thinking very hard myself not to get it mixed up. Negative 1. Oh my gosh, I got it mixed up as I was saying it. 1, negative 2. I was fearful of mixing it up. 1, negative 2. Got it. As long as the scale is by ones, and we'll assume that it's not written on there. All right, that is the answer. You put it in parentheses, or you could be very specific about it like this. For me, either way. Number 9, let's check it out. Let's see here. Oh, this looks like actually point slope form. So let's see if we can just take it just the way it is without moving it into slope intercept form. So it looks like we have a slope of 4 with a point 2, 7. So let's go 1, 2, 3, 4, 5, 6. Just fits on there. Y minus 7x minus 2, yep. So the slope of 4 from this point, well, I'm going to go back 4. 1, 2, 3, 4, and down. 1, 2, 3, 4, and down. 1, 2, 3, 4. I'm counting here. Oh, making kind of a mess. And, well, good enough. I think that's what we got. And then our other equation, a little easier. Y-intercept of 4. 1, 2, 3, 4. And going down. There's the intersection. I see it already. My board is getting more off kilter there. But so that intersection, if I have everything right, is 1, 2, 3. 1 comma 3. All right. And if I were to plug 1 comma 3 into both these equations, it is the only combination of numbers, it's the only single combination of numbers that would satisfy and correctly have both of those equations equal. Only one time. You can't cross twice or more when you have two straight lines. Got to wait till parabolas or a second degree or third degree function to cross more than once. So here goes. Now we're talking, here's the meat and potatoes. We're going to do graphing, substitution, or elimination. And the idea here is you're allowed to use one of those things only once. And so there's a strategy to this that I don't think everybody picked up. Like, one of these is much easier to do let the calculator handle it with the graphing, because you can graph on the calc. Another one is much easier to use elimination, and there's another one for substitution. So I think if you just dug into it and just looked only at number 10 alone, and you kind of just didn't look at the other ones, and you just decided on number 10 which method you're going to use, you might have chosen the hard way, because I think there's easier methods for certain ones. For example, if I were to do this, I would look at number 10 and say, well, graphing, no. For number 11, graphing, I don't want to do graphing. So number 12, it's set up for graphing. In fact, these fractions are kind of scaring me. I don't want to have to deal with them algebraically too much. I could make a mistake. So I'm just going to stick that right into the calculator. I think that's the best thing to do. So it would have been nice if I had this already prepared, but yeah, not there. This is some other problem. So you set it up, 1 plus 1/3 x. And I'm going to let the calculator handle this, 28/3. It could be done, other methods. I mean, it certainly could be done substitution or elimination, but the 28/3 is going to just make a lot of things into fractions. And, all right, we're ready to graph. I don't know if our graphing window is going to hold the answer here, but perhaps it will. I know the answer is not too big. And the answer ends up being a fraction anyhow. All right, now to find the exact intersection, what you do not want to do is mess around by using this cursor and trying to line it up. Even if you hit trace, I'm only tracing along one line, but it's still skipping. Every time I hit the right arrow, that's pretty close right there, but even that's off. It looks like it's perfect, but if I were to zoom in super close, we would see we're off by a little bit. Because every time I hit the arrow, it has to go up a certain amount, and that's all programmed depending on how big the window is. So it's not going up any normal, like, predictable number. So there's a button to actually get the exact answer, and it is on the calc menu. Go to calc, and of course it's intersect, 5th one down, and it's got 3 questions for you. First curve, second curve, and guess. By asking you first curve, it's simply just asking you, is that the first equation? Yes. Second equation, yeah, it probably should say equation instead of curve. I think that confuses people because we got straight lines. And the guess is only for more advanced things when the lines are intersecting more than once. It wouldn't be lines, I suppose. It would be curves again. And you want to, maybe you're only interested in one of the intersections of many, and so you put the cursor closest to the one you're interested in. For our purposes, you just hit enter 3 times really fast, and we have an answer, but it is 2.5, and then 1.8 repeated, which is really like, as a fraction, exactly 11/6. Whoops. So I got kind of a decimal and a fraction together there. Why not? But you can put 2.5 and what was it, 1.83 repeated. That's okay, too. All right, so we took care of that with the graph. Hopefully that wasn't too much of a problem. I got 2 left. Which one of these should I use substitution for? Substitution is when you get one of the variables all by yourself, and I see that that one has a variable almost all by itself. I could solve for x there. What I'm going to do, I'm going to rewrite this because with the 2 equations getting kind of together, it can be sloppy. I'm going to move the x over on this side just to make it positive, and I'm going to move the 14 do this, subtract the 14 from this side at the same time. So the x moved over. On this side, on the left-hand side, I have negative 7y minus 14 equals, on this side, x. I've solved, in this case, for x in terms of y. And I'm going to put that x, I'm going to put this expression into the second equation and replace that x. And I'm just going to be really careful because there's a lot going on here, so I'm going to get rid of all my extra stuff. You would just go, further down in on your page. But I'm kind of limited here, so I'm going to rewrite this second equation. Stop, and I'm going to be extra careful about positives and negatives. All right. Now again, I'm using substitution here. Why didn't I use substitution here? I could have, but I think it's just a teeny bit harder. And when I think about elimination, maybe people were thinking, well, it's easy to eliminate these, and maybe eliminate even those, not bad to multiply by certain things. And they're absolutely right, it is. But this problem here, substitution's a little tough for that one, so that's why I chose it. So I'm sticking to my guns. Let's see here, for positive, all right, here we go. That's positive, that's positive. Just want to be real cautious. And I got, 56. And that's not multiplied, not distributed, that just stays. All right, now I'm going to subtract 56 from both sides. All right, and I'm going to do 28y minus 14y, bring together these like terms, and I got 14y equals negative 28. And if you don't mind going down, we divide by 14, and I got negative 2. Negative 2. All right, great. Take that negative 2 and put it into either equation, whichever one you think might be a little easier. I'll put it in the top one. And I'm going to solve for x. I got y. Let's solve for x. So I'm going to substitute again. Just be careful about this. Is where people, all these little signs. That's positive 14. So watch, when I subtract 14 on both sides, I get negative x equals 0. And guess what? Just x equals 0, right? I can divide by negative 1 on both sides. So x equals 0. And those are my two answers there, 0 and negative 2. How about that? All right, great. 0, negative 2. Let's do the last one here, which is in the middle, number 11. Have to eliminate. All right, one thing that makes this problem hard is that we have x's and y's on the left side here, but then we have a y and an x kind of on different sides. I really want to take care of that first. This is kind of bugging me. So I'm going to put everything, I'm actually going to I'll keep this top one like this, but I'm going to bring this 5x to the left-hand side. I'm going to bring that 5x over, and I'm also going to kind of line them up. Plus 8y equals negative 20. All right? I just moved that 5x, moved it over to the left-hand side by subtracting 5x, and I just lined them up a little bit better. All right, elimination says we have to literally eliminate or add together terms so that either x's or y's are removed from the problem. And I'm going to take the lowest common multiple of 5 and 2. Of course, that's 10. All right? I see some people tried the 72 with the 9 and 18. And I guess you could do that, but things get the numbers just get really large. Remember, we have to multiply everything times 5 for this equation to kind of remain equivalent. I'm going to multiply this entire equation by 2. Just be careful about how you're showing your work here. I'm going to, let's rewrite this equation down here. So I got 10x minus 45y equals 40. Great. And then my next equation, everything's multiplied by 2. So I needed these to be opposite, right? So I didn't have to multiply by, negative 2, because this already had a negative, and it was going to end up eliminating. So I don't need that negative. I don't want that negative. That makes this positive 16y, and this makes this negative 40. All right, that's kind of interesting. These just happened in the problem to eliminate. That wasn't something that had to go that way. And I got negative 45y plus 16. Well, hold on, those are going to cancel out. And it doesn't even matter what that is, however meant that is. I'm going to do my math on the fly. I think it's negative 29y, but it doesn't matter because y has to be 0. All right, we got y is 0. Circle that. Plug it in. Now you are substituting in this problem, you're substituting 0 back in, but you used elimination. It's not like you're cheating and using substitution. This just has to happen this way. And this won't take long. I'm going to plug 0 in right there. So 2x minus 9 times 0 is like 0, right? 9 times 0. So I really have 2x equals 8, and x then equals 4. So that was elimination. Moving on to the last page of the test, back and forth. Now we're moving on to linear programming. All right. Now this first question, it's not the best. I guess it's not the most clear. And what I wanted to do is I kind of wanted this to be a separate question after the word dough there. It just didn't end up being its own question, which is okay. But I was trying to lead you through like step by step, and then in the next question, number 13, it was all kind of all at once put on you. But let's keep track of this. We got a lot going on. We got donuts, we got pizza, and a lot of information that you can't really handle all at once. You have to break it down. So I see that I can make at most 70 donuts. All right. And I know just from pre-reading this, I don't ask about this specifically, but I know that I guess that is not its own question. But I know, but the number of donuts cannot be greater than 70. So it didn't ask you to write that, but you can just put that up there. Because now it does ask you a very similar question. You can make no more than 40 pizzas. We'll use y. All right, so then we got something going on. Make sure we remember x is pizzas, y is donuts. And let's see, y is no more than 40 pizzas per hour. All right. When I talk about the balls of dough, that's probably coming up in a bit, but just put that on the back burner. It says, of course, you cannot make negative numbers of donuts of pizza, so using x and using y, write the inequalities to represent those constraints. Well, I can't make negatives, so that simply just means x has to be greater than 0 and y has to be greater than or equal to 0. I guess I can make none, but I can't make negative. All right. That's kind of a trivial, it's not the most important thing ever. It's kind of obvious you wouldn't use negatives. All right, moving on. Your dough making machine can only make 100 balls of dough per hour. All right, this is important. Each donut requires a single ball of dough, but a pizza requires 2 balls of dough. All right, that's repeated. That's the same thing that was written up here, so it seems pretty important. I wrote the same thing twice just to try to make it clear. So an inequality for that would be that you have single ball of dough for donut, right? Oh, wait. Let me fix. Did I do that right? Donut. Oh, for crying out loud, I got the x's and y's mixed up. All right, check that. If x is... I got my donuts mixed up. Let me do this. Sorry. There you go. No, it made me think that. I just had it mixed up. All right, so single ball of dough, because I was thinking this way. Pizza requires 2 balls of dough, right? Donut plus 2 pizzas can only make 100 balls of dough per hour, at the most, you know? So this can be no more than 100. All right, so donuts and pizzas. This is keeping track of your balls of dough. That's one of the constraints. That is definitely a constraint. Now we graph all this in Desmos. What are the coordinates of the vertices of the feasible region? Well, what are we graphing? Okay, so what equations are we graphing? Go to Desmos. You're definitely going to put that one in. You can put these 2 in, but these are, like I said, sort of the trivial ones. And we're going to put that one and that one. Believe it or not, that's enough. All right. And what you get, I don't have Desmos quite ready, so I'll just put them down here. What you're going to get is, you're going to get a line that kind of looks like that, a line that looks like that. And everything's shaded underneath. So let's see. Where they're both shaded is here. And you're actually going to get a shade. If you did those trivia ones, you're going to get a shade. Let's see what color I could use. I'll erase this in just a second. But you're going to have everything more than x then y equals 0, and you're going to have everything over in this direction also. And the only place where everything is shaded, all 4 constraints are shaded, is in that blue area. So let me back up. This is really the area we're looking at. All right, now, the coordinates we were looking at for this thing were here, 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 and that little intersection there. So, again, 0, 0, kind of a trivial, but I guess there is a chance in some certain other cases where it just makes sense to not make anything at all. You're going to lose money if you start making anything. So 0, 0 might be your weird answer in that case. 7 is, let's see here, 0, 0, 0, 40. All right. 20, 40. I'm not sure where that one was, but I have it written down here, so we'll stick with it. And whoops, 70, 15. All right, and that must be 70, 15. It must be somewhere in here where it counted doubly. All right, I wish I had the Desmos up, but I don't. But you stick that into Desmos. Much easier, of course, to put it into Desmos than to put it into your TI-83, and even better than having to do these by hand, where you find the intersection of all these points. But the idea is you find all these coordinates, whatever they are, and then one of these sort of is the winner. So how is that possible? So these are the coordinates. Here's the thing that we haven't discussed yet, and it wasn't even given to you until the problem down here, is that the constraint for the profit is 1.75x plus 2.25y. And that just equals, set that just equal to your maximum. We're trying to profit, so we want this to be max. All right? So we put all the vertices of our shape into our equation. So for example, 0, 40, if I were to put that in there, that would be 0, and there'd be 40 y's. And I keep track of all the things that are going on there, all right? And then I keep track of 20, 40. I put in 70, 15, 70, 0, and 0, 0. Of course, wouldn't make any money at all. And I got a winner, all right? For example, if I put in 20, 40, it's not a winner. That gets $115, which is not as much as the winner, which is 70 and 15. All right, that gets you $135. So they should make 70 donuts, and check which one was which. 70 donuts and 15 pizzas, and there's no better combination. All right, you can't make more than 70 donuts, remember. So like anything else, I was about way out here. Let's see. Way out here, this is like a hundreds, comma 0, and some people were thinking, well, maybe it could be that, but remember you've got a constraint. The x number can't go over 70. All right, there's that. Now in the next problem, it's kind of all just flopped in front of you, and there's really, it doesn't go A, B, C, D, and break everything apart, so we got to handle this. We got chocolate chip and peanut butter muffins. For the life of me, I don't know if I've ever had a peanut butter muffin, but I was making this problem up. I was trying to think of something strange. I must have been hungry also. And we got, oh, tails. Should say takes. Does that say takes? Nobody told me. Tails. Well, 3 cups of milk and 3 cups of flour. Okay. So we got peanut butter. Let's call these the X. All right. Because as I read through the problem a little bit further, and we'll do that in a moment, we realize those are really the variables. Not flour and not milk. They're not the variables because we actually know we have numbers of those. Okay? So let's see here. 3 cups of milk, 3 cups of flour for the peanut butter. So 3 cups of milk. Just kind of writing this down. Flour. And then they talk about the chocolate chip muffins taking 4 cups of flour, 2 cups of milk. 4 flour, 2 milk. Cool. At home, Chef Dean. Suppose that's me. That's 48 cups of flour and 30 cups of milk. That is a constraint. That's the most you can have. So that's starting to remind me, oh yeah, that's what's constraining the problem. You know, each of these takes a little bit of flour and milk, but I can't use any more than what I have. All right? And it says if you make $7 for each bag of chocolate chip, here's the money part of it, right? The money, the profit. So $7 for each batch of chocolate chip. So remember that's Y. And $5 for every peanut butter. What's the maximum profit? All right. Well, remember we deal with this later, so that's sort of one of the last things we deal with after the graph. So how are we going to handle this milk and flour thing? Well, one thing we haven't put it into equation yet is this part here, right? So let's get to it. Cups of flour. 3 cups of flour for every X, for every peanut butter muffin. And it takes 4 cups of flour for every chocolate chip. And I cannot use more flour than 48. And I'm going to do the same thing with the milk. 3 milks plus only 2 milks can't be over 30. And that is what you're looking for. Those are the constraints. There is a minor constraint that probably not making negative amounts of peanut butter muffins and chocolate chip muffins. So this would also be part of it. You head into Desmos, you graph these two things, and what you get, I'll kind of draw a quick graph of it. I won't be super accurate. My scale here went a little bit too far because really we're only going to go up to, we go about from 15 to 10. There's a line that kind of goes like that. And there's another line that goes from about 12 and goes across to about 16 or so, somewhere in there. All right, and then lower than that. So not all the way up to the green line on this side, and not all the way to the red line over on that side there. So we're stuck in here. And you can't make any negatives, so we wouldn't be over here in quadrant 2 or 3 or 4. No worries there. All right, we take a look at the corners. And in Desmos, it's awesome. You just put your cursor right there, and it tells you that spot there was 4, 9. And we could be down here at 10, 0. Or we could be over here, make this real obvious. We could be on the y-axis there, and that was 0, I want to say 12. Yep. All right. And other than 0, 0, which I'm getting the feeling that's not going to be the right one, but that's also a corner there. All right, we got the 4 corners. Nothing along here is going to be part of your answer, right? Has to be along the vertices. So one of these 4 guys is correct. And we take each one of these and we plug them in. All right? And we plug in 10, 0. We get out, let's see, we get out $70, right? When we plug in 4, 9, I'm going to get $28 plus $45. All right, little side math here. Ooh, that looks like $73. Did I get that right? 28 and 45, yep. If I plug in, oh wait, I plug it in, hold on. I'm getting my Y's and X's mixed up. Redo. 10, 0, there's my X, is $50. There we go, sorry. And 20 plus 63, all right, there you go, $83. Because I was putting it in directly there. And 0, 12. 0 X's and 12 of those is going to surprisingly be 12 times 7, $84. It's actually, and it's a shocker, it's actually better to not make any peanut butter muffins and make 12. Use all your ingredients and make as many chocolate chip muffins as possible. No wonder why. Nobody likes peanut butter muffins. I don't even know what they are. All right. Whew. So there's that. And of course, the 0, 0 one's a trivial. Of course, you don't make anything that makes sense and not make any money at all. There's that. So that is your answer there. Now in the bonuses, if you want to get down to that, here goes. Create a set of two linear equations that has a solution of 6, negative 4. All right, let's do this. In one line, one slope has got to be negative 2/3 x. All right, that'll be my first one. Take care of that. But I need this line to go through 6 comma negative 4. Well, if I plug in 6 right here, I'm going to get 6 divided by 3 is like 2. I'm going to get that y is negative 4. I don't need a different y-intercept other than 0. I don't need one. So it is kind of like this would work. Just the way it is. Awesome. That's it. So that's one of the lines. It has a slope of negative 2/3, and it goes through this. All right, good. The other line, all it has to do is go through this point and that point. All right, strategy there. Let's see. It just says linear equation. I can write it in any form. So let's see. If I write it I'll write it in point slope form. Y plus 3 equals, I don't know the slope. It doesn't say it has to be parallel or perpendicular or anything weird like that. So I'll leave that blank. But if I'm doing point slope form, pretty easy to think of it like that, right? All I have to do now is force the slope to be sure to bring that point in under the in the line, right? So I got to plug in 6 and negative 4 and just watch what happens. So here it goes. I'll go down. I'll leap down to this next problem down here. Negative 4 in for y. Don't know the slope yet. Times 6. All right. 6. Oop. Hold on. X minus 6. That's what I wanted. All right. So we got negative 1 equals. No, I wanted 6 in there. Yeah, there we go. I did want 6 in there. 6 times x. Divide by 6. Divide by 6. Let me just catch up. My brain is gone south. Here we go. The slope, though, for our problem is negative 1/6. That's a true fact. So, our equation can be, our other equation, y plus 3 equals negative 1/6 x. All right, let's just make sure before we leave this problem, because we had some bumps in the road. I need it to go through this and this, so let's just make sure. If I make x 0, and I make this side negative 3, yeah, if I make this side 0 right here, that's 0, and I make this negative 3, we have 0 equals 0. Got it. So that point will work. If I want to try 6 comma negative 4, a little harder, put negative 4 in, I will get negative 1, and plug in 6, and I will get negative 1. Phew, despite all the troubles, I got it. You don't have to use point slope form or anything like that, so this could have very easily could be in slope intercept form by subtracting 3 on both sides. So either way, I'm going to check, I would check the bonus to make sure any of those are correct. All right. There, made it through. All right, next bonus. Clear this out. This next one's actually a lot easier, I hope. Slope intercept form, okay, check. Line perpendicular to that goes through this. Well, point slope form is going to have this problem done in a minute. If I didn't have to explain it, I'd already be done with it. Here's the slope, right? Because this format is kind of, I guess it would be considered point slope format, the way it is. So the slope is negative 3/8. Well, a line perpendicular to that has a slope of 8/3. And I have a point. And in the point slope form is just going to love this. So it's y minus 6, right? Take that 6 out, equals positive 8/3, because perpendicular slope is the negative reciprocal. Parentheses, x minus negative 3. There you have it. That is not in slope intercept form, though. I know what you're thinking there. This is still in point slope form. It was right for point slope form. So all I have to do is multiply this out and add the 6 on the other side. So I do have to finish it up. All right, well, let's see. Let's clean this up. I'll add 6 on both sides, and I'll multiply the 8/3 out like that. So don't forget about add the 6. And I get 8/3 x. 8/3 times 3. The 3's will cancel, and I'll get 8. And so that 8 plus the 6 is 14. That's my story, and I'm sticking to it, and you made it all the way through the video, right to the end of the bonus. Hey, take it easy. We will see you in class.